So today we're going to remember how to graph some stuff a little bit, but we're going to talk about piecewise functions some more today. And it's important to be able to sketch these following functions here. What shape is this first one? It's x squared. It's a parabola, yeah. Yeah, it's a parabola. Anything with something being squared is a parabola shape. It passes through 0, 0, 1, 1, and negative 1, 1. It also passes through 2, 4. How do I know that? Because I could do an XY chart. If I plug in a 2 and I square it, what do I get? A 4. If I plug in a negative 2 and I square it, I will also get a 4. So that is a parabola shape. Now, this middle one is also a parabola shape. It has an x that is being squared. So it is the same U shape, except this one is being shifted. What does x plus 2 do to the graph? Left 2 units. And what does the minus 3 do to the curve? Down 3. And so this is just being able to recognize what is the shape of the thing that we're looking for, okay? And then this is just how it's being shifted. So all I have to do is take the same curve, which started out at 0, 0, 1, 1, and negative 1, 1. And I'm just going to take those 3 little dots and slide them left 2 and down 3. So I'm just going to count left 2 and down 1, 2, 3. And I can make that same triangle of dots there. And there's our little parabola shape, just about there. Okay. What would happen if I put a negative in front? What if I put a negative in front of the x squared? What would it do? Yeah, if it flips upside down, if it was negative, it would just be an upside down one. If we put a negative in front, we would have started with an upside down parabola and still shifted it left 2 and down 3. So it would just be an upside down from this point right there. Okay. All right, last one. What shape is this graph? Straight line. This is linear. This is x to the first power. It is a straight line. You'll notice it's in y equals mx plus b form. Very good. I like this color blue. It's very pretty. Okay. And so we can see B for begin here. Where do we begin? At negative 3. Yeah, on the y-axis, we begin at negative 3. And then the slope is the number in front of x. And what does that slope tell me to do? Yeah, up 1 and right 2. So from my beginning point, we're going to go up 1 and right 2. Up 1, right 2, and I get a slightly inclined line, just about like that. We are going to use these same graphing skills today to make our piecewise functions. And if you remember what we talked about yesterday, piecewise functions are just functions for specific x values, okay? And that's really the only difference. It's a collection of functions, but for very, very specific x values. And so instead of having arrows on our line, we might cut the line and only use a part of it. So today what we're going to do is we're going to graph the line and then only keep the part that we want. All right, I'm going to show you how to do that. It's my favorite technique for graphing piecewise functions. You're going to want a pencil and you're going to want to write very lightly, okay, until we're done. Example 1, graph the following. Going to graph the following. F of x equals, got this big curly bracket. So this entire function here, negative x plus 1. I'm going to insert the word for in there. For x is less than 0. And x minus 3 for x is greater than or equal to 0. So a piecewise function is made up of pieces of the curves, of pieces of lines or pieces of curves. We'll see. Depends on the equation that we have. For specific x values, and in this particular case, and everything you have today, we have a worksheet today, there's going to be a switch where we're changing from one line to another line. And that change, I'm going to say right here is where we're changing. I'm going to call that our boundary line, or maybe I'll call it our change line. And we're changing around x equals 0. We're using the top line, this top equation, for x values that are less than 0. And we're going to use this bottom equation for x values greater than or equal to 0. So things are changing right here at x equals 0. Do you see how that works? Okay. What I'm going to do is I'm going to go ahead, and you might want to do this. Things are going to change right around 0 here. 0, x equals 0, is a vertical line. So I'm going to go ahead and just draw in a little line right here, this vertical line right here at x equals 0. And that's where things are going to change. Can't really see it because it's right on the line there, but then what we're going to do is you're going to take your pencil, and we're very lightly going to graph this first line. Negative x plus 1. This is the first line we're going to graph. And then what we're going to do is we're going to graph the entire line, and we're only going to keep a part of it. We're going to erase the thing that we don't care about, okay? We're going to keep what we want. So this is in the form y equals mx plus b. Where should we begin to draw this blue line? At 1. And so I'm going to make a big dot at 1. And then what's the slope? Negative 1, yeah. Right there, that slope is negative 1. I'm going to change it to a fraction, negative 1 over 1. What does negative 1 over 1 tell me to do? Down 1 and over 1. Down 1 and right 1, always to the right. So I'm going to do that. I'm going to go down 1 and right 1, and down 1 and right 1. I'm also going to reverse. I want to go on both sides of my change line here. So I'm also going to go up and back 1, up 1 and back 1. So I can then connect my line, my dots here, and you're going to lightly draw it in, very lightly. This is the entire line. You'll notice my arrows go on forever to the left and forever to the right. But I only want this blue line for x values less than 0. Where are the x values less than 0? Second quadrant. Yeah, that's true. Here are your x values. Here we have the x values that are less than 0. All the x values to the left. That's what we want. So do I care about this stuff to the right? No. So we're going to get rid of the stuff to the right. We only want to see that blue line for x values less than 0. And these are all the x values less than 0 to the left of our little change line that we drew in. Now there's one little problem here. Right here, this is for x values less than 0. Should I use an open circle or a closed circle? An open circle. Right at my change line, I'm going to use an open circle right there because it's just a less than symbol. If it was equal to, we'd want to fill it in and make it solid. Okay, but it's just less than, which means we're not actually including that point right there. It's a pretend point. We get really, really, really close to it. So we only want to see that blue line for x values less than 0. Now we're going to graph the green line. It's in y equals mx plus b form. Where should we begin on that green line? -3. We're going to start at -3. I'm going to put a big dot there. -3 on the x-axis. And then what's our slope? +1. Yeah, that slope is +1. I'm going to make it a fraction 1/1. And then that tells us to go up 1 and right 1. So from my beginning dot, we're going to count up 1 and right 1. Up 1 and right 1. I might also want to reverse that and go the other direction, maybe. And so I get this very, very, very long line that would normally go forever in both directions. But I don't want the whole line. What do I want? Yeah, greater than or equal to 0. We want x is greater than or equal to 0. That would be like 1 and 2 and 3 and 4, everything to the right of 0. That's what we want to keep. So we're going to keep that right-hand side, and I'm going to ignore and erase the left. At 0, we have an equal to bar. So we want a nice solid dot right there. That point's included, but the open circle is not included. Does this pass the vertical line test? Kind of. I like that answer. Okay. So the question would be right here. What's going on right when x equals 0? There's an open circle and there's a closed circle. Which one is included? Yeah, the solid dot there. And this one is not actually there. It's infinitely close. You're exactly right. But it's not actually defined. Okay. So there really is only one point here. All right. The open circle just gives us something to reference, just to get close to. All right, ladies and gentlemen, do you see the relationship between our change line and the side of the line that we see? Yes? Yes? Okay. Let's try some more. We have our function here, -x plus 1, for x is less than 1, and our function 1x minus 3 for x values greater than or equal to 1. And we're going to make a little sketch. Where are our blue and green lines going to be changing up? At 1. Very good. So you can see right here, it's pretty easy to see that we're going to have a change happening when x equals what? 1 in this case, yeah. We have values to the left of 1 and we have values to the right of 1. That's where things are changing when x equals 1. So I'm going to go ahead and make that my little boundary line. You don't have to do this. This is just for reference when we're learning how to do this. Oh, I'm going to write that at the top just so you can see it a little better. There we go. So we have this boundary line when x is equal to 1. And so I'm going to start graphing this blue line, negative x plus 1. You'll notice, is that the same thing we just graphed? It is the same. It has a y-intercept of 1. And what's my slope? Negative 1 over 1. That tells me to go down 1 and right 1, and down 1 and right 1. And I could draw that line in, then a nice big long line, but I don't want the entire line. What part of that line do I want to see? Stuff that's less than 1. Yeah, x values smaller than 1. Is that to the left of my change line or to the right? Left, yeah. X values less than 1 is everything to the left of 1. So that's the side that we want. And I didn't need this side to the right of my change line. What about, it is an open circle, very good. Right here we need an open dot at 1. So I'm just going to circle that with a big open dot there on that change line. All right, and then we have x minus 3. That is a y-intercept of negative 3. Now, I do want you to be careful. When we're graphing this, we always start on the y-axis here. So we're starting at negative 3 on the y-axis, and that's not on my change line. So you do need to be a little bit careful. And then from here, we have a slope of 1 over 1, which tells me to go up 1 and over 1, up 1 and over 1, up 1 and over 1. So I have this big long line that would normally go on forever, but this one is restricted. And right now, is this a function? Does it pass the vertical line test? Does not. Right here, we got stacked up functions. They're stacked on top of one another. That's not allowed. So you know you've done something wrong, okay? Which side of this pink line do we need? The right-hand side. We want x values greater than 1. X values greater than or equal to 1 is everything to the right of that little change line. So we're going to keep that side and erase the left. And what should we have at 1? A nice closed dot, yes. Nice closed dot right there. So you're going to see incremental changes on this worksheet that we're doing today where I'm just changing pretty much the boundary line. And so you can see how things just change a little bit. All right, questions on this one? Does this make sense to you? Okay. And you can see how we have x equals 1 and then we have x values less than 1 is everything to the left and x is greater than to the right. This blue and green graph, that's what we're the goal. That's the solution. All right. All right, so I'm also going to throw in some parabolas. So we have f of x equals negative x squared. For x values less than or equal to 0. And we have negative x plus 2 for x values greater than 0. What shapes are we graphing now? Yeah, right here we have a parabola shape. All right, so we know that that's that parabola shape. And what's this green shape here? A line, yeah. Uphill line or downhill line? Yeah, downhill line, because that negative slope. Good, good, good. Knowing what the shapes of things are is like so important. That's like 90% of algebra is just knowing what to expect, okay? All right, where is our little change line? Where is all the change happening? Yeah, right here. X is less than or equal to 0, and x is greater than or equal to 0. So something is changing when x equals 0. All right, that's where all the change is going to occur. So I'm going to put myself a little reference line to remind me, on one side I'm going to have one shape, and on the other side I'm going to have a different shape. So at x equals 0, I got my little change line. Now, I did that for a parabola. Is this an up parabola or down parabola? It's a down parabola. Yeah, I should have drawn that one. And it doesn't have any shifts on it, so I know that it goes right through the origin, and it's going downward. So it looks something like this. I'm just going to dot it in like that. Which side of that parabola do we want? Left, yeah, right here. This is, we want for x values less than or equal to 0. Less than or equal to 0 would be to the left of that. So we're keeping this left-hand side of the parabola, and I get to get rid of the right-hand side. I don't want that right-hand side. At 0, should we have an open or closed dot? Closed dot, yeah. Why? Because it's equal to, yeah, it should be nice and solid dot there. Perfect. All right, and then we have our green line here. Y equals mx plus b, so it begins at 2. And then it has a slope of down 1 and over 1. So down 1, right 1, down 1, right 1. Which side of this line do we want? Yeah, we want this for x values greater than 0. We see it right there. Only x values greater than 0. That's everything to the right. So do I need to go backwards and do the left? No. I can just keep going to the right. What should we have at 0? Open or closed dot? Open. Yeah, open dot. So I'm going to just put a big dot, open dot around there. Does it pass the vertical line test? Yeah, it's all good. It's perfect. It's a function. It's what we should expect to see. Okay? All right. One more with a slight adjustment. The last 2 days of notes are super easy. This is the last thing. That's really weird. Filling up my water like that. Okay. So we have negative x squared plus 3 for x values less than or equal to 1. And we have negative x plus 2 for x values greater than 1. Where are things changing up? Oh, well, they're both changing. Yeah, they're both negative, that's true, but they're changing here. Changing when x equals 1. We're switching from blue to green when x equals 1. X equals 1 is right here. All right. And we're going to graph the blue portion for the x values less than 1. Is that to the left or to the right of our pink line I drew? Yeah, that's x values less than or equal to 1. So I want to make sure I'm graphing my blue thing to the left of that line. And what's to the right? The green thing, yeah, x values greater than 1 would be to the right. All right, what shape is my blue thing? Parabola. An up parabola or down parabola? Downward parabola. Very good. What does the plus 3 do to it? Up 3. Very good. It does. It's just up 3. If it was inside parentheses with the x, then it would move left or right. But this is on the outside. It's going to go up 3. So it was right here, upside down u. But then it's going to be shifted up 3. So I'm just going to move these points up 1, up 2, up 3. So now it's like this. And we have this lovely, lovely parabola shape. Those 3 dots I started with aren't really there. Should I keep this portion that I sketched over here to the right of my pink line? We only want the blue to the left, so I'm going to erase that section and keep my parabola, my shifted up parabola. That's pretty good. Sort of, kind of. At 1, should we have an open or closed dot? Yeah, nice solid closed dot right there at that boundary changing line there. Okay. Now, negative x plus 2. What's my beginning point? Where do I begin? 2. Right there. And then what's my slope? Negative 1 over 1, which tells me to do what? Down 1 and right 1, down 1 and right 1, down 1 and right 1. And I only want my green stuff for values greater than 1. So just starting right here at this boundary line, I'm just going to keep going on to the right. At 1, should we have an open or closed dot? Open, an open dot. Very good. Nice open dot right there. Now, if I hadn't had this parabola be shifted up 3, what if it was just a plus 2? Where would this parabola be? It's just a down 1 a little bit, yeah? So be here, starting here. And then these 2 points, they'd be stacked on top of each other. Is that okay? It is okay, actually. Yeah. Exactly. Yeah, this one's not really there. And if this slid down 1 unit, they'd just be filling in that hole, okay, which is just perfect. So sometimes they will start and connect, I will say. Sometimes they may connect, okay? Do you have questions for me? All right. I'm going to pass out a worksheet.